Hello everyone, today we will learn the every rate of change again, and maybe you can have questions why we have to learn this one twice, because this one is very important for you to learn the derivative later when you learn calculus. And this times we will find the every rate of change for all functions. Last time we find the every rate of change when they give you the functions as a formulas. But today we learn some more things. One more things about when they gave you they ask you to find the every rate of change, but they only give you the functions when they give you the graph, not the formulas anymore. First of all, what is the every rate of change? So if they give you the functions as a linear functions, and they give you two other pairs, I can call it this one is x1, y1. This one is x2, y2. Then the every rate of change actually is the slope. The slope, you already know how to find the slope by using the formula y2 minus y1 over x2 minus x1. And if I write the every rate of change of slope as a function notation, so let's y equal to f of x. And they ask you to find the every rate of change of this function on the interval x or a to x. This is the every rate of change as a function notation. So we still have the same thing. So every rate of change equal to f of the second number is f of x subtract f of the first number is f of a over x minus a. So what happens if the function is not a linear function? It can be any functions. Like in number 2, you can have the quadratic function, polynomial functions, or rational functions. So if it's not a linear functions, let's say it is a quadratic functions. If this one is quadratic function, let's say that, then they ask you the every rate of change on this interval. What is that about? So this is from a to x, and since you have this one is fa and this one is fx, so the meaning of the every rate of change of these functions, f can be any functions, not linear functions, on the interval 8x is the slope of the secant line passing through those 2 points. Slope of the secant line, not the slope of the curve, the whole curves on this interval. So we still have the same idea, we still have the same every rate of change. This will be the slope of the secant line passing through the 2 points. Okay, so now we can apply this formula to show some problems on the handout. I will show number 2, B and C, and you show the rest of those numbers. Number 2b. Find the every rate of change of function kt equal to 1t minus 1 on the interval 2 to 6. So we use the every rate of change formula applies for this functions. We will have k of the second number is k of 6 minus k of 2 over 6 minus 2. K of 6 equal to, substitute 6 for the t over there, so you have 1 over 6 minus 1, subtract 1 over 2 minus 1 over 4. That equal to 1/5, subtract 1 over 4. So this is a complex fractions. You can simplify this complex fraction by use the LCD method, but with me I just combine the top and then divide the denominator later. So this one I have 1/5 subtract 5/5 over 4. That becomes nearly 4/5 divided by 4. Flip over the denominator, so I have this one equal to nearly 4/5 times 1/4, and it's equal to nearly 1/5. So this is the every rate of change of these functions on the interval 2 to 6. To see, they ask you to find the average rate of change of this function h of x equal to 3x squared plus 1 on the interval -1 over to b. So this time b is not any specific number, it's just a b. So we will have average of change on this interval will be equal to h of b minus h of -1 over b minus -1. H of b is equal to 3 times b squared plus 1 subtract. So h of -1, I will put the whole thing I have in the parentheses. -1, so I have 3 -1 squared and plus 1 over b plus 1. Simplify this one to see if you can simplify something more. So I have 3b squared plus 1. This one is 4, so subtract 4 over b plus 1. So I have 3b squared minus 3 over b plus 1. I don't see any common factor between the numerator and denominator, but I can tell if I take out the 3, I will see something after that. So I have 3 out first. This is b squared minus 1 over b plus 1. Then I have 3b minus 1 times b plus 1 over b plus 1. Hey, I see some common factor. I simplify that. So this average rate of change will be equal to 3b minus 1. And this is the average rate of change of this function on this interval. You can try with 2a and 2d. That's not new. I believe you can do that. Number 3. Number 3, you might have question. This is deal because this is they give you the functions as a graph, not the function as a formula. So number 3. Number 3, I will give you the formulas for this one. Similar questions, similar problem, and then you will try the rest, like 3a, b, c on the handout. So if I give you, this is the graph of a functions. And I know this is a functions because I can use the vertical line test. I can tell this graph is represent for functions. So this time I ask you to find the average rate of change of this functions, I call it f of x, on nb, or nn, or nn, just that. With n and n is two order pairs on the graph, and of course order pair you can tell when they give you graph, you can tell the coordinate of that. So I can say this one is 1 and this is 4, example. So this is 4 and this is 6. So how can I find the average rate of change of this function on this interval from n to n? So same idea like at the beginning of class. The average rate of change of this function on this interval actually is the slope of the secant line passing through n to n. So they don't give you any order pair, but you can read the order pairs or the coordinate of n and n from the graph. So I will have, let's say, this time I had n have the coordinates is 1 and 4, and m had the coordinate. You can read the coordinate of the two points on the graph. So you have this is point 6. So the average rate of change will be equal to y2 minus y1. That means 6 minus 4 over x2 minus x1 is 4 minus 1. This one is 2 over 3. And this is your average rate of change. So in general, if you have the function they give you just a graph, so the average rate of change on A and B can be any order pairs with A has the coordinate xa, x sub a, y sub a, and B has the coordinates x sub b and y sub b. Then the formula for this one, average rate of change equal to YB minus YA over XB minus XA. So you can use this formula for question 3 when they give you the function as a graph. I don't think it's a big deal for you. Number 4, just applications, and but same thing. They give you the interval 1, 3 already, and they ask you another question about the average rate of change of the functions on the interval with the second numbers is just have a variable on that. But I think you can do that. But first, I would like you to try it to show all the problem on the handout by yourself first. And when you struggle or when you're done, you want to compare your solution or your answers, you can compare with the solution keys later. But don't forget to try first before you take a look or compare with the solution keys. Okay. If you have any questions, just let me know on the Hangout, Google Hangout. I already send you an invite to join in the class daily from the times on the email also. Check it out. If you have any questions, please send me an email. I always check my email during the office time or daily. Thank you.